Okay, so we're going to look at some special cases today, and in particular, a difference of two squares, how to factor those. You may have done that in the past. And then how to factor two cubes, either a sum of two cubes or a difference of two cubes. Normally I say let's not do the shortcut first because it's good to understand why before we jump to the shortcuts. But I'm going to give permission to use these. I'm going to teach you some shortcuts. I will show you how to do it without the shortcut, but then I'm going to just have you use the shortcut on these for a couple reasons. One, with a difference of two squares, things are just going to get too big and too long for you eventually if I don't allow you to use the shortcut on that. And then sum of two cubes and difference of two cubes, you'll see why when I talk through it. It's a little bit over your head. So I'll talk you through it, and then we'll work on the shortcut there. So let's start with the difference of two squares. What's really important is that you recognize I'm doing these together because sometimes they get confused. Typically we teach the difference of two squares first, and then later on, almost at the end, teach this, and then it's just things get blurred. So I want to teach them side by side so you can see the difference between them automatically. Okay. So let's start with number 2. We're going to do this through the long way without the shortcut, and then I'll show you the shortcut. So we have two terms, x squared minus 1. We can change this to three terms by writing x squared plus 0x minus 1. It is the same thing, but I'm showing you the middle term is nothing. It's just 0x. But by writing it that way, we can now use what we did with three terms. We can play that little game and say, what two numbers multiply to what? -1 and add to what? 0. So what are they? What two numbers multiply to -1 and add to 0? -1 and +1. So then we change that middle term, keep it like terms, so to -1x and +1x, bring down the x squared, bring down the -1. So it's still the same piece. So we went from two terms to three terms to four terms. But we got four terms now, so we can factor by grouping. So we look at the first half, factor out an x, we're left with x minus 1. Look at the second half, factor out a 1, left with x minus 1. Then we look at both these terms, and they both have an x minus 1, so we factor the x minus 1 out, and we're left with x plus 1. Okay. So that's why it works, that's how it works. You can turn all these into a trinomial and do what we did yesterday with them. But I'm going to allow you to go from the original straight to the answer. Okay, that's going to be our shortcut. So let's do that with the first one. To use the shortcut, first you want to know, okay, when I factor a difference, what does that word difference mean? Okay, so you have to have a difference to do this. I'm spelling subtraction wrong. Sorry. Let's try that again. Okay. So it's got to be a subtraction sign between two perfect squares. And we have that in number 1. And so when you factor it, you're going to get two factors. Each factor will have two terms. And those two terms will match. So like what times what is x squared? Well, x times x. What times what is y squared? Y times y. One will have a plus sign and one will always have a minus sign. It's just the format. I'm not explaining why. If you want to know why that works, look at number 2 and do the process with number 2. So I'm just helping. I'm pointing out what to do for the shortcut. Okay. So we're just going to practice that shortcut again. So number 3, is it a difference of two perfect squares? Yeah. And so we're going to get two factors. What times what is x squared? x times x. What times what is 49? 7 times 7. And then one with the plus sign, one with the minus sign, you factor. So it's a pretty, once you're used to this is the easiest type of factoring out there. It's really nice and easy to do this. By the way, would it work with this? X squared minus 4x. If I asked you to factor that, is it a difference? Are there two things? Are they both perfect squares? No, not quite. Almost, right? So how would you factor that one? Yeah, that's a factor at the GCF. So careful, because that's a tricky one. Some people think, oh, that's a difference of two squares. It isn't because of that x. It messes you up, right? How about number 4? Is that a difference of two squares? Yeah. This right here is what times what? 7x times 7x. And this is 1 times 1. So they're both, 1 is a perfect square, okay? And so we're going to have 7x plus 1 times 7x minus 1. How about number 5? Is that a difference of two squares? Okay, so what times what is 49x squared? 7x times 7x. What times what is 25y squared? 5y times 5y. And one with a plus sign, one with a minus sign. So this is a shortcut. Shortcuts don't show you y. And so whenever you use a shortcut, make sure you're allowed to use it. Okay? And so question now. That's a difference of two squares. Let's consider a sum of two squares. So x squared plus 9. If I asked you to factor that, what would that factor to? X plus 3, x minus, x plus 3. Okay? And how can we check? Multiply it out. So if I multiply this out, I get x times x plus 3 plus 3 times x plus 3, which is x squared, plus 3x plus 3x plus 9, which is x squared, 6x 9. Are those the same? No. So actually, that's not the answer. It seems like it should be, right? But it doesn't work out. So what if factor 2 then? Yeah. So let's try again. X squared plus 9. We want to factor that. Yeah. X minus 3 squared. So let's try that one. So x minus 3 times x minus 3. All right, so x times x minus 3 minus 3 times x minus 3. We get x squared minus 6x plus 9. Is that the same? No, still not the same. 2? X minus 3 times x plus 3. That would be negative 9, yep. Okay, well, let's go back to how would we actually factor it without a shortcut? Because you guys are trying shortcuts right now. That's what you're doing. So let's go back to how to do that without a shortcut. What would I have to rewrite it as? X squared 0x plus 9, right? And so then we think, well, what two numbers multiply to what? 9 and add to what? Okay, so tell me, what two numbers multiply to 9 add to 0? Negative 3 and negative 3 and positive 3? Well, that adds to 0, but does that multiply to positive 9? No. Try again. What two numbers multiply to positive 9 add to 0? 9 and 0. It adds to 9, right, and multiplies to 0. So you had it flipped, huh? Does it work? No. So what does that tell you about x squared plus 9? It doesn't factor. Okay. If you have a sum, if you have a plus sign between two perfect squares, it will never factor. And you got to remember that. You can only use a shortcut when it's a difference of two squares. Sum of two squares, never going to work. All right. Is this a sum of two squares? No, this is a sum of two cubes. Okay, so now we're transitioning to cubes and whole different thing here. And before we do, I want you to try a multiplication problem out. Go ahead and multiply a plus 2 times a squared plus 2a plus 4. Multiply that out, see what you end up. Okay, so if you did your multiplication right with the minus 2a instead of the positive 2a, you would get a to the third plus 8, which is what we're studying, a sum of two perfect cubes. And actually, it's related to what number? Number 7, right? Okay. Where did I put that? There we are. Okay. So let me ask you this now. If I started with a to the third plus 8, and I asked you to factor that, and you went through a bunch of work to factor that, and you got to a final answer, what would your final answer be? A plus 2 times, right? Because this is multiplication, and multiplication is going this way. If we go the reverse way, we're factoring, right? So if I start here and I want to factor, my next line would be this one. And then my third line would be this one, my fourth line would be that one, and my fifth line would be that one. That factoring is the reverse of multiplication. And so let's see if we can make sense of this factoring. So let me find my highlighter here. Okay, so we're starting with what was at the end. And then this is the second to last line. Can you see kind of why that would be our second move for factoring? Why we'd want to write a to the third plus 0a squared plus 0a plus 8. Does it make sense? That kind of like we're filling in what's in between. There's an a. It's like a place value. We got your a cubed. There was no a squared, so I'm just put 0a squared. So you're maintaining your place values, and we had to do that with the difference of squares to go through the factoring. Okay, so we can kind of see where that one comes from. It's the next move that is kind of mysterious. We see that we're going to have to split up the 0a squared to 2. Somehow, this gets split up to 2a squared minus 2a squared. And that's a little mysterious to us. And the other one also needs to be split up to a negative 4a plus 4a. Right? That's the part where like, how would you know to do that? This one we just bring down. This one we just bring down. And when we did it with trinomials, we made up a game to help us split it up. Remember the game? What two numbers multiply to this and add to this? Okay. And I could probably make up a game for you that would work all the time on this one, and then have to come up with a different game for this one. But we're going to be taking a shortcut. So Remember, I'm just going to show you this once, and then we'll look at the shortcut. But I just want you to see where things would come from. And so the third step is really the mysterious one. This one right here, kind of how do we split that up? After that, everything should make some sense to you. So what happens now is we group these in sets of 2. We're used to 4 things, so we got 6 things. We're going to do the same thing. And we look for the greatest common factor of each. What can I pull out of the first 2? A squared, what's left? A plus 2. What would I pull out of the second set? Negative 2a, and we're left with an a plus 2 again. And the last set? 4, and we're left with an a plus 2 again. And then how would we jump from that to the final answer? Do you see how all 3 of these have the same common factor? They all have an a plus 2, so you pull out the a plus 2, and then what's left is the a squared minus 2a plus 4 remains behind. So if I made you do this the long way, that's what it would have to be like, okay? But as I said in the beginning, we're going to learn just to go from the start to the finish without any of the stuff in between, okay? So in order to do that, we got to look for some patterns. How do we, if I give you a cubed plus 8, how do we just jump to that answer? Okay. You guys see any patterns? Let me so look at that and look at the answer, and let me give you another one because this will help you look for patterns. Say I had x to the third plus 27. That's a sum of 2 perfect cubes. We know it's going to factor to 2 things times 3 things. Can anybody come up with what you think it might be? Just by looking at this and following a similar pattern. What do you think would go in what do you think the 2 terms would be? X plus 3? That we're thinking? Or no? And you're right. So you see some pattern, you haven't said what it is, but you had to see some kind of pattern to come up with that. What would the pattern be? Yeah. So we're taking the cube root of x cubed, we're taking the cube root of 27 to get x and 3. Yeah. Oh, you know, what would it be? You're right, Kaya. Can you help us out that don't see why that's true? Okay, so you know you got to end up with an x cubed, she's thinking. So if you have an x here, how are we going to get the other 2 x's? So you got to have an x squared somewhere. That makes sense. And then what else? Oh, you're thinking through the multiplication, aren't you? You're thinking deeply. That's good. I'm looking for a more surfacey pattern. But yeah, she's going through the multiplication. What would it have to be in order to cancel all that middle stuff out? That's good. But hold your thought. Let's look at another one real quick. What if I had this? 64 x to the third minus 8. The difference of 2 cubes, but it's going to work the same way. We got 2 terms times 3 terms. Anybody guess what the 2 terms are? Let's work with that. Luis. Sue? Yes. Okay. 4x minus 2, because 64 is 4 to the third power. You were thinking square, right? You got to think third power. And then this is 2 to the third power. So you can kind of see where the 4 is coming from, kind of see where the 2 is coming from. Challenge would be, how do you do this next part, right? You know? What do you think? Okay. There's a pattern, yeah. Close. Okay, let's go back to the first now. Let me start to show you guys are seeing some things. Here's what I do. Okay. I get my first piece here from this one. I get my second piece here from this one. Okay? So I don't look at my original to help me here. I only use the original to help me with this one. And you guys are picking up that pattern. To come up with this one, I work with these things, these two things. So I do a times a, I do 2 times a, and I do 2 times 2. Right? A times a gives me a squared. 2 times a gives me the 2a. Yeah, it's a negative. I got to work with that. But it's a 2a. And 2 times 2 gives me the 4. Over here, x times x gives me the x squared. X times 3 gives me the 3x. Yeah, it's negative. And 3 times 3 gives me the 9. But you see where those are coming from, right? So let's try that on this one. We'll get to the negative for it. And hold off on the negative. Just see, don't worry about the signs yet. See if you can come up with the other part. So what would the first piece be? 16x squared, because that came from 4x times 4x. What's next? 8x, because we're going 4x times 2. You think it's a minus sign or a plus sign? Kind of where we're not sure. It is a plus. Here's why. These two signs will always be opposite. Okay. And then what do you think the last part is? 2 times 2, which is 4. Now, to remember the signs, here's what I do. I spell it soap. See if I can spell soap. Okay. SOAP stands for, S is same sign. Okay, because these two have the same sign. O stands for opposite sign, because these two have opposite signs, or you can, however you want to see that. And AP, what do you think? Always positive. So SOAP helps you remember what sign to put there. Okay, and so there's a few patterns going on in here to do the factoring, and let's just practice that now with these pieces here. All right, so a to the third plus b to the third. We have a sum of 2 cubes. When you have cubes, sum or difference, they will factor. It's the squares that you got to worry about. Okay, so first factor, you got to know that you got 2 terms. Second factor, you got 3 terms. First factor comes from this. You take the cube root of each of these pieces. What is it? A, and it's plus because it's the same sign, SOAP. And we got B, okay? And then these 3 terms come from these 2 terms, right? We go A times A, and put that there, A squared. And then SOAP, opposite sign, so I'm going to put a minus sign now. And my next term is going to come from A times B right here. I'm going to put that there, A times B. And then my last sign is always going to be positive. And I use B times B to get the B squared. And now it's factored. All right. So let's try number 7. Oh, number 7 we already did. So I'm just going to write it here. So we got the a plus 2 times a squared minus 2a plus 4. Okay. So this also works on a difference of 2 cubes. So number 8, what will the first factor be, the smaller one? A minus 1, same sign here. And the next factor? A squared, because you go a times a gives you the a squared. Opposite sign plus, because we used the minus sign here, so we got to use the opposite here. Plus what? Plus a, because you're going to go a times 1, which is an a. And then always positive 1. So you try number 9 and number 10. See what you can do. Okay, so number 9, what are we getting? What's the first factor? A what? A minus b. Same sign, right? And then the second factor, a squared plus ab plus b squared, right? Because you got the opposite sign here and always positive here. And then 10, you had to know that 343 is what to the third power? 7 to the third. 64 is 4 to the third power, so we use that to help us. And so our first factor is going to be what? 7x minus 4, because we use the same sign. And then 49x squared plus 28x plus 16. You guys see where those are coming from? So the 28 is from 7 times 4, right? 49 is 7 times 7. 16 is the 4 times 4. Okay. All right, so I'm going to give you a few minutes to get started on your homework. And then I have an activity for us, okay? So.